Wow, what a turnout. Holy smokes. So we're on the third version of OTP server, distributed objects, and those type of things. So we'll talk about it from the server perspective today. Usually what I like to point out when I'm thinking about the server is major words we kind of made up to describe it and what we mean when we talk about it. If you think about the server, there's a bunch of pieces, and a lot of our, when we talk about it internally, we talk about it this way. And they're words we just made up. They just mean something to us. The first one we use, and you'll see CA in a lot of my diagrams, we call them client agents in the mix. And the server, there's another thing we call a message director. And we have another one we call a state server. And we have another one we call a database server, kind of more classic. You kind of get what that one does. We have another piece of the server we call the event logger in that space. And then we have kind of this hybrid thing that's a specialized state server that's pretty new, but we call it the DB state server. So those are the core major kind of functional units, standalone things provided by the OTP server, which, if you don't know the history, OTP stands for Online Theme Park. So that's our online theme park server that's going to help us build an online theme park. That's what we're building in our philosophy. So Dave already talked about in a previous lecture about the DC system, and there was some other talk about zoning and interest. So I would definitely suggest you look at those videos. We can get you all the links. So I won't go to, I have no choice but to cover some of those, but I don't want to spend too much time on there because they're covered pretty darn good. I'll cover some of the server side things that come with that space. So the main part of the whole server, if you think about this server infrastructure, is you got to start by thinking about the message director. The fundamental reason for this server is it's a register and subscribe kind of space. It's about, think about, we've got state motors running our engines and playing the games, and somehow we've got a call, very great kind of graphics call, what you care about and what you see, because you just don't have enough bandwidth. I can't tell everybody about everything. So somehow I got to kind of trim this down and allow developers the ability to control that trimming down. So that's kind of the whole reason most of this exists. So the calling is one of the main objectives. And I don't even know if I'm using the wording calling right. I'm not sure that's the right word. Did I even spell it right? You guys are laughing. I'm looking at it going, I don't mind. I can't spell like a right code. The next kind of thing that comes into space is persistence. There's two levels of persistence that we had to solve in this kind of multiplayer space. One is kind of just an instantaneous, tell me about something, but it doesn't really have to survive long. It's my position in space is important, but if the site reboots and I come back up in a month, does it really have to be the exact same position? So there's a lot of data like that. So the other one is long-term persistence. You can imagine it's classic database. You've given me $10, you want me to remember you gave me $10. There are certain things that we want to keep. So persistence is kind of the other problems that the servers are trying to solve. The other reality that comes into some of this space is kind of two other engineering objectives that came. One, and they're both kind of side effects. One is the reality is you got a lot of people want to do some nasty stuff. They want to go out and they want to hack you, and that's how they play the game. They got to see if they can bring down Toontown, see if we can crack pirates, see if we can steal gold, see if we can whatever. So there's a lot of what the server work goes on in the server is security driven. It's about, we don't trust a client. I know you guys that write client code want to think you guys, as I visualize the server guy, you guys are necessary evils. The game is here, and you guys are just these, mother may I set my location, mother may I get some gold, mother may I move my car, mother may I do things. The server really gets to say no at some point because he's the security god. And the server being the grand scheme of all these different processes. So security becomes a big issue when you think about some of these, and it's something you got to keep in mind. Security, the other, I totally lost my brain on the fourth one I wanted to talk about. Security scaling, lengthy bandwidth, it wasn't that important if it's not on the list. Design principles when we were building the system where we're at in the kind of a, when we were first building it and thinking it through. Scalability, you know, how do we get these things? We'd all played other MMPs where I wasn't allowed to teleport to my buddies because they happened to be on the Baja server and I was on the Florida server. So I had to call them up and give them 20 bucks to allow to play with my cousin and those type of things and that type of space. So we wanted to try to avoid that where all possible. So we took a little different approach than some other servers have taken, very less centralized, more distributed messaging system to allow for much bigger virtual space. The bad news is it carries a lot of baggage and headaches with it. The other kind of engineering principle we took, and you'll see it as I draw these and think these through, is I would rather have loosely coupled, finely tuned processes that do their job well, and although we kind of link these sometimes into one big executable, there's no requirement to do that. I think of it as a Unix pipe metaphor. I'm really, that seems to really help us, at least me, grasp the space when I'm totally walking out your camera. So I hope audio tracks work. But as I think through the space, we're building things like pipes. That certain pieces do certain core things, they do it well, and they don't do anything else. And we kind of lay these pipes in sequence. So as I draw these pictures and I start connecting them, you'll get what I'm talking about in the pipe space and these things. Bandwidth's expensive was the other metaphor. You've heard it, you've had two speeches already on the DC system and what it's utilized for. Historically, when we first started this, we targeted the clients had to run on a 14.4 connection. So that's when we first started all this work. So bandwidth was expensive. The good news is bandwidth ain't so expensive. What's cool now is that we've got so much tight infrastructure that compacts our data and keeps it tight. We can now put a lot of stuff on the wire. It's not bulky to say things. It's pretty compact. You gain the historical benefit. I don't think we still have the bandwidth limitations we had at one point in the space. So what is this thing, this OTP server, conceptually? For most of you guys, you get this thing called OTP.exe or OTP server.exe or OTP_cars.exe or something like that. You start it up on your system. We put in one big binary, and for most Windows kind of developers, every process, every instance, everything that happens. The reality is, at one point in its life, and they still build this way, each of these can be totally separated. They're not required to run in the same space. How do you pull that off, Roger? What are you doing? Well, it's the same thing we do with AIs, is it all boils around the thing called a message director. It's just a word we picked to describe how we're going to communicate and what this contract is between me and other consumers of this space to get data through the system. So if you're a small talk coder, you're going to love me, because what the message director is a big thing. It's a big register and subscribe motor that says, I care about this particular piece of change, and anybody that wants to change something or do something in that space knows how to fulfill the contract and publish those changes, those instances, those data sets. Very specifically, what a message director does is it moves around messages. It directs the messages. That's where it got its name. What a message is in our system is a message is literally a binary encoded hunk of data. And you'll see it both in the Python implementations, you'll see it in the Java implementations, you'll see it down inside the Flash implementations. There's a concept of a message, and it's an invariant. The core is it has a max length, well, technically it has a length field that's 16 bits. Those 16 bits govern the remaining length of the field. That's exactly how it's encompassed, so therefore a message in its entirety has a max length of 65,500 and plus 2, because the length is part of the message. So that's the max. Bad news is you can't put anything more on a message. If you want to have an atomic unit of delivery and you want more than 65K, don't use a message. It's a bad place to be. That's not what it does well. Start thinking of other technologies if you want to do batch downloads. We tried some things sometimes to do, I remember back, we tried to do patching or something. Somebody was hacking around. I'm trying to remember. Remember back there?
Yeah, we're sending the description for the factory.
Yeah, somebody was trying to do interactive scene editing kind of space, and they were rebuilding it and compiling it and then trying to distribute it. And you really don't want to be in this space. It's not what it does. It doesn't have any grouping of messages. It doesn't have all there's other protocols for that. So that's what a message is. Now, this is pretty weak. This is just a hunk of packets of data. There's nothing really here that makes it a message, because there's no contract of how it behaves. Nobody understands. Obviously, if I just put this on the wire and give it to this guy, he's going, okay, it's this big, now what? What do I do with it? Well, the next question is, what are we talking about? Who are we trying to communicate to? The next thing in a message in this space is we put 8 bits on a message. The next 8 bits are the count of channels, is the word we use. What a channel is literally 64 bits, and that's it. It means nothing more. There's 64 bits on a message that says, I'm talking about this 64 bits. So we have 4 billion times 4 billion possible combinations of things we can talk about and abuse. And we abuse them in all sorts of ways. Fundamentally, it's just a way of saying, I'm talking about this, and somebody downstream knows that it's going to consume this. It's no different than an IP address, if you think about it. It's really a contract between the two recipients. I'm this IP address, you're this IP address, we're going to talk. They really have no meaning short the recipients, and the guys in the middle know how to respect them that are routing things around. So, but the thing you may not realize, if you're a current consumer of the system, or may think of ways to abuse, is you can have, in this space, and I'm limiting you now to 127 physical targets for any particular message. So you can be, I want to send this message to channel A, B, C, and D. So you can put multiple 64-bit values on this. This is very low-level kind of talk. That makes it a fully formed message. There's nothing else required for the message director to do its job. Everything else is noise as far as it's concerned. Obviously, we use this other extra area that's in a message space to represent things we're trying to communicate, and we can encapsulate other things in that. But for the message director to do a job, it needs to know how big. It's got to be a well-formed, structured message. It's got to have a recipient, or it'll just get dropped on the floor the second he gets it. You could technically set this to 0 and put nothing there, and you won't like the results because the results are no op. You're not going to get anything out of the thing. So you're looking at me and going, okay, Roger, what's the value of this stupid thing? Because now I can send a message to A, B, C, like you talked about. Well, you need another protocol to top this off, which is, hey, I'm interested about A. You need to be able to tell the message director, I care about A, I care about B, I care about C. I want to hear about these things. So there's another protocol you can actually register in this space. Now, most of this is hidden from you. I don't think I need to go into deep bit dissection and all of this. The code's there. If you're really curious, I can pull it up. But there's a way to say, I want to register both at the C procedural level, or at the Java, or at the Python, or at the Flash level, to say I want to register a particular channel. I want to register for channel A. And there's a way to say I want to unregister a channel A. Obviously, by using those two, you're now listening in, and I like to equate it more to listening into a phone call and less of an end-to-end communication. The reason it's more of a phone call, we all live as engineers in Disney, we suffer through the, let's have a meeting, let's all meet on a phone session, and everybody dials in, there's beeps going on, and constantly people are chiming in. It's a group phone call. It's a way to think about most of the usage of this system. So any server in the world, and we do have AI servers hanging out here someplace. We have world servers, we have things we call Uber dogs, we have who knows what, some hack patch system that we're going to write a patch that's going to fix something, things that hang off on these. This is how they get kind of into this, and I use the word lattice, and lattice means something very particular. But this is how they get hooked into the lattice of the communication stuff, piece on the sleeve. So how do you abuse this thing? So you now have enough to be a message director, consumer, and producer. Cool. I, as a developer, now I want to have a server on one end, and I don't know, let's say I want it to be a time management server. And I have another consumer server on the other end that wants to be a time consumer. And I could do something like say, hey, I want to put all time management communication on channel, because I own the cluster, I can do anything I want. This is how we do it. We can say, I'm going to put all time management communication on channel A. Channel A is probably more something like 100000001. You know, that's really what it turns out to be when we kind of allocate it. But logically, it's on a channel A. And in that channel, they both kind of listen and they talk and they handshake and they make communication. Well, that works. Now, what we've done for most of the protocols is it works to an extent, but you don't have any concept of who the hell sent that message. So the next thing we added to the protocol was on 99.999% of our messages, in fact, every message beside these type of messages, because they're not broadcast, we have the the next thing that hits in the channels, in the message structure, is a 64-bit who. Who sent this thing? Identify yourself, talk about yourself. The advantage here is in almost every single case, when we put a who on here, we're basically telling you how to get back to the person that sent the message. So you do have a round-trip path if you want to use it. Ideal things would be is inside a Python AI or inside a Java AI, some client connection sends you a message like set my XY position, and you want to tell them no. You think you got a hacker on your hands. You want to boot them off the system. You want to do something like that. You know who that was, and you can talk back out to that client connection because he's got his own unique 64-bit channel. We assign everything in this system. It's got its own unique channel of some case. Most cases, that channel is literally the first 32 bits are 0, and the rest are in 32-bit space. If you hear people talk in our community when we're talking about it, we call those DUIDs, Distributed Object IDs. So we've limited ourselves to 4 billion objects active in the cluster at once. You can only have 4 billion, so hopefully that's enough to get where you need to be. That's how you talk to an object. So we usually reserve the low 32-bit range to indicate distributed objects. The word is DUID when you hear people say it. I can get lost in this one deep. We can go deep in this, but we only got so much time on this space. So let's step back up a little higher level, and don't worry too much about the messaging. And let's get back to how do I use this system, Roger? What is this thing? Great, I can send messages. So you have enough today to reverse engineer and talk from one server to another, but what the hell is this database thing, the state server thing, the DB state server, the client agent? And, you put out here, you got clients. Client could be Flash, it could be Python. You could have an AI over here that's today is going to be Java. You can have different processes floating around here. They're talking into pieces of the system. How do I make these work, and what are the pieces to make this work? Well, the importance of the last two videos, and again, if you haven't seen them, see them. There's a lot of value into looking in the last two, is we have 3 big concepts that we've abused this message director system with. One of the concepts we call is interest. That was Josh's last week's message. We have another concept, distributed class, DC system in this space. We have another concept that's closely related to interest we call location in the space. So and it's a circular definition, so it's hard to give you a starting point, so bear with me as I kind of drill down into this space. So we know that a DC class is a schema that lets us define, hey, a thing we're going to call a bike has a front wheel and a back wheel, and they have a rotational speed. And so that's an integer. We're going to put an integer on that, and it's got a color of blue, and it's got all these other things that you do in the stay in the camera space. That's what that gives us is it gives us as programmers, developers, a common way to communicate, a common way to talk about it, a common way to think about it. It also gives us a contractual schema for serialization and behavior. That if we follow the basic rules that are in this DC system, the pieces that support the DC system, including ourselves, well-behaved systems, will do the right things with this data. So the DC, not only will we've described a way of programmers to talk about it, we've described a way for computers to talk about it. The bad news is computers don't use big things like distributed bike. They use class number 2. They use a number that indicates those things, and it's a runtime generated number in those. But they're definitely talking, in computerese, that's a distributed bike. That's a class number 2 type of thing, and it's a field number 4. So we've got a DC system that's a schema, but more importantly, it's a contract of behavior. The DC system has some other fields in it that start relating to other pieces of the system. So it's got your fields and it's got classes, but it's got these weird things at the end they call attributes. I think the attributes are the right word we use. But weird kind of, what is this? What is this CL send and this AI receive and this broadcast and these other strange text strings that are put on this? That doesn't look like C, that doesn't look like any language. What is that stuff? Well, that's more of a contract of behavior in the system. You're advertising, you're either addressing security, you're addressing some calling issues, or you're addressing some persistence issues, which are the major design objectives of the server. I can't imagine what a field that says, what is it, DB, what is it, just DB?
DB.
What does the field DB mean? Well, it probably means I want that thing stored in a database. So in the Toontown instance, we've veered a little away from this in some of our newer instances because we're trying to use more specifically driven schemas. But literally in Toontown, if you put a DB field on an avatar, the next time you instantiate an avatar, there's a DB field on that avatar. It's done. You don't have to do anything. It just happens magically when you store the data. So that would be, a field like set name. My name of my avatar, obviously I want my name of my avatar to be the same next time I log in. So a field like set name or something like that has an attribute called DB. What that tells the system to do is as somebody sets that value in the well-contracted model, make sure that data gets put out to disk. We still fully support this. We're doing it in cars. We're doing it in ferries. We're doing it in pirates. They're all using slightly different techniques. Literally in the ferries version, we don't have this part of the system running. We don't even turn it on. What we do is we have a clone of this system that acts more of a wedge, and it's doing the exact same function, but it's talking out on this end to an SQL system. But it's conceptually the same thing. It's a contract to get the thing to the data store, and it's not quite as flexible as doing it dynamically because SQL has its own schema mechanism. Other fields that interplay with these pieces. Let me step back. So we got DC, it's a schema, it's everything else. What is this magic thing called location? We all know what location is. I'm standing in this room, X, Y, Z. Well, not quite. The bad news is everybody that's done video games know you have, 9 degrees of position or 6 or 7. It depends on the type of game you're doing. It's a different type of location. It's probably a bad word, but it works for game engineers because they get the calling model. You have in the world of interest, not the world of XYZ, in the world of interest, this abusable world, cool interest space, what is my location? Location on any distributed object is an absolute singleton. You can only have one and only one location. So what the location really is, if you look at this thing, is how we implement it. The location is really a 64-bit number. I have a location of 64 bits in this space. I can't imagine why we pick 64 bits. If the whole reason is to call things in the world, now I can, in my intellectual way of thinking about position and space and calling and doing things, I can take a 64-bit location, I don't know, let's put an interest in there. And I have a concept of a 64-bit interest. Well, this is what I'm looking at. This is my camera in network space. This is stuff I want to understand. So I have interest on stuff I want to hear. Sounds kind of like registering to a channel on the core message director. And I have a 64-bit location that is where an object is at. What that mechanically does. So I've got a client out here that's got an avatar running. Let's put some lines between these guys. Make this stuff work. I've got an avatar out here that's got a location in the world. He's standing there, and I want to change his telemetry. I want to change, he's moving a foot forward. So I'm going to say my X position now is not 20, it's 21. So we send up here, I'm going to say set X to 21. I send that command, and what I do is I send it to DUID my avatar. Well, what does DUID my avatar mean? Fundamentally out here, my avatar is a 32-bit number, because we know DUIDs are 32-bit magic numbers. There is literally, on a state server, because the state server's job is to govern state, is an object called myAvatar, and it's got a bunch of instances of fields and values and a bunch of magic code that makes it behave well behave inside the contract that we're fulfilling with the DC system. So the client says, I want to set my avatar. So literally the flow of the thing is the client agent gets the field up here, and I'll start introducing you to the features of the client agent and other pieces. The client agent's main front end on here, because security is one of our major concerns, we decided to put most security after some other tests way out on the edge of the system. We used to have it scattered throughout the system. Didn't work very good. It forced everybody to think about security. So now we're moving, it first hits a security model. The thing's going to look at it and go, you want to update your avatar to send the setX position to the magic avatar manager and somewhere in here, and it's going to look in the DC system and say, oh, that field, you are the owner of your own avatar, and that field is marked owner send. Therefore, you can send it. Somebody else was to send there, they'd probably get logged out because they're not marked as the owner of that avatar. So owner send is a security field. When you see one of those flags in the DC system, that's what it's telling you. It's telling you, okay, that's a security, and what I'm telling is only the owner of this. The only instances we have today of owners is every show has the concept that the avatar is owned by the puppeteer, the person playing that particular avatar at that instance. The only other exception today is ships and pirates have a way of getting the ownership set to a particular person. I can go to the details, but that's the only usage we have of owner today. There's no other owners of anything in the whole system. So that's an owner send. So the client agent, in its infinite wisdom here, he's got tons of connections, just tons. Each client agent, let's say he's got 1,000 open connections or something on this, just talking out to the internet. So he gets that field in here, he decides, okay, so he's allowed to send it. Literally all he does is kind of encapsulate a message, and every distributed object in the system is guaranteed to be listening to the channel that is its DUID. So if you take the first 32 bits, set them all to 0, add the next 32 bits and make it the DUID of the object. It's an absolute unique identifier. It's the primary key for you database guys of the object in this scope of work, this scope of space. So he's going to send a message to anybody listening on 00000, my avatar's DUID, whatever that magically is. Well, it just so happens a well-formed system is going to have a thing out in the state server that's listening to that avatar ID. And literally what it is a bunch of C code that's got an object in memory that represents your avatar. That is the avatar as far as I'm concerned in the game. I don't care what the AIs say. To me, the avatar, the system of record, is the avatar on a state server. So that's going to get routed through the message director, and it's in infinite wisdom. It's going to find the guy listening to this, and he's going to send that message to the state server. State server is going to get that thing and say, cool, that's a field that's marked as RAM. I wonder what RAM does. Well, RAM, we have to deal with persistence. Persistence is one of our problems we have to solve. RAM means I want a persistence of RAM, not persistence of DB. I want a persistence of RAM, which means I want a photostat of the last update value of that field. So he literally takes a picture of that, stuffs it in memory, and keeps it for prosperity, and we'll get why he needs it in a minute. Then he notices that this field, which was RAM, is also broadcast. Broadcast's a weird name, but it works. At a conceptual level, what broadcast means is anybody that's close to me, anybody that should see this, anybody that's listening to my zone, listening to my location, listening to where I'm at, should hear about this. This is a field that's supposed to be broadcast to anybody that's interested in my location. Usually we use the word location and interest to deal with 2 or 3 dimensional space. It's I'm on an island, it's everybody within a region of me, I'm in, that type of stuff. It doesn't have to be done that way. I have prime examples. So literally what the state server does, he gets that value and goes, okay, everybody, this is a broadcast field. He sends this message right back on the wire. Keep in mind there's plenty of client agents. In a production cluster, we have literally in the space, we have a hierarchy of message directors, but in the end, I think we have 5 boxes with 6 client agents running Pirates today. So we have 30 client agents in the cluster running. He sends the message, and what channel does he put it on? Because the only thing you do is send it to channels. We abuse the channel structure, and we know the channel is just a 64-bit number. So he sends it, he literally just sends it right back out that channel. So there's a well-formed contract between the interest guys and the location guys. He just puts it on the channel. Meanwhile, over here, somebody that's watching you stands beside you in your guild or something. He's watching what you're doing. He's in the same race with you, or he's flying a ferry around in the same meadow you're in, and those things. He's listening to channel my 64-bit number, or my location, the location. So that channel hits the message director, and its magic lattice clustering model guarantees that it'll get sent out to that client. The good news is there could be 100 million of these people listening to that channel. It's literally a 0-to-0 end-to-end communication. There's guaranteed to have no writers, but you could have 1 million writers, and you're guaranteed to have no listeners, but you could have 1 million listeners. It's kind of what the message. That's why it's different than TCP. It's a what they call the deterministic multicast space. So that's for broadcast. Specifically when we talk about locations and channels, because it's that circle. This is a weird, strange circle when you define this stuff. It's really hard to get until you get it, and then it's like, boom, it's stuck with you. A location and an interest. What we use to describe and come up with these magic 64-bit numbers where things are located and I'm interested in and those things, we try to model it in hierarchy. We try to think about it conceptually as a multi-dimensional space. We try to avoid graphs. It is kind of possible to do graphs, but you don't want to go there. So it's literally a tree kind of concept. And what we do is, since our DUIDs, and we've got to somehow merge all this back into a security model. We got to get all this kind of working about what I'm allowed to send, who I'm allowed to send, what I'm allowed to see, and those things. We cut this in half, and we make two 32-bit values at a conceptual level. The mechanical implementation is still 64 bits. But for the human presentation layer, and also some of the languages that use it, we cut into two 32-bit spaces. And we use the word parent and child for most location-based metaphors. That you have a particular parent of an object, and you have a child, and when you can put those two together, you come up with a magic 64-bit number. Well, this works in two places that are kind of cool. One is, I'm guaranteeing that 32-bit numbers are unique in the system. I have to. Distributed IDs got to be unique. You can't make them up willy-nilly. You got to follow the policies and the rollout of the system you're in about how you get numbers for what a distributed object is. So if we say really that both of these are conceptually distributed objects, I guarantee two things. It comes out cool. One is, it's unique. That combination is going to be unique, because I'm thinking a parent and a child. The combination of the two parent child makes an absolute unique 64-bit number, which computers love to throw around fast and move quick, but people can talk about it. Humans can talk about the district has an island. The safe zone has a collision to a door. The ferry has a buttercup to pick up. The car will have a finish line. There'll be something there, and you can have that kind of conceptual space that humans can understand. So it's a way of communicating. The other thing it gives us is, it seemed pretty strange to have some preconceived notion on how these numbers would be used. Do you want to offer this to anybody to use anyway? Some people just want to say, I've got everything in zone 6 on all my districts are, C zones. Are in zone 100 in Toontown, I think is Toontown Central, or 1000 or something. There's some very well-known structure, and it's just easier to have the client know the constants and not deal with discovery mechanisms to find them. So the good news is the rule and the policy we have is, in any particular site that's running together, the DUID, that's the parent, owns the rules for the below it. It's a conceptual model. It's an agreement between programmers. What it is if you're contriving as an AI server or as a client, or people trying to abuse the system, you get to make up your own rules, and you get 4 billion possible combinations underneath every instance of one of those objects you have. That's a good thing. You may not want to do. We've abused the rules to do Cartesian zoning. There's literally, you have a floating windows of zones. I can go over that if I can get to it. I'm going slow. I'm covering too much detail. The circle. So the circle, interest and location. Although location is supported by state servers, interest is only supported by client agents. You really, as programmers, have two type of interfaces you got to deal with. You're coding down in this bottom half of the world. If you think about, and this bottom half is, it's the down the metal. You can do anything. You can cut your wrist. Our belief is, if you're coding in this space, you're a trusted server. You're allowed to pretty much do anything you want to, and if you want to, you can write bad code and bring the whole site down. I don't care. It seemed to be a better model than putting all sorts of weird security restrictions on ourselves type of space. So the bad news is you also don't get some of the features that we took the time to develop for a client and those type of things. One of them is interest. Interest is a solely controlled behavior of a client agent. There is no such thing as an AI interest. AIs don't have location-based interest. What AIs do have, because we wanted AIs to know about things, is obviously a point that the 3D world wants to know that it probably wouldn't be things like your set name. I'm not sure the AI really cares what your name is. It's kind of a wasted space. You might, but you probably may want to know telemetry. I can see why an AI wanted to know telemetry. You want to know AI collisions. You want to have AI avatar interaction, NPC interaction, those type of things. So what we have is another DC field. It's that big circle again, and what it's called is a whole different type of interest. It has nothing to do with location. It has to do with controlling AI. And what we call is AI receive. there's a field, another attribute you can put at the end of these systems that says AI receive. When you put AI receive in it, what it means is the particular 3D world that you're currently manifested in, because you can jump 3D worlds in our space, you're not stuck to one. The current 3D world that's governing your positional world logic will receive any updates and also receive this when you enter into the world. So that's what the AI receive means in the thing. So that's another type of interest. Has nothing to do with client interest. AI receive. Okay, so what else we got? So it's all hunky-dory, and let's go to the bigger pieces, and then I'll open it up a little. Database server, you get event logger as a developer. What's the event logger? Event logger is this warp on the side of the whole system. At some point, we got to the point where there's a lot of stuff I want to know about. There's just some stuff, and it has nothing to do with kind of governing. It has to do with forensics. It has to do with longevity. It has to do with just understanding what's happening, quantitative data. A lot of people call it instrumentation and those things. And at one point, we thought about having logs. I mean, literally today, I think for Pirates, how many Pirate servers, AI servers, do we have running? 50?
25.
25. We're probably at some point going to have 50.
Yeah.
I'm not excited about scraping 50 logs every night and pulling out the stuff, and also worried about the poor guy that put catastrophic core dumps and those type of things in their logs, which really I don't care about for events, major events that affect the system. But we do have a server out there. It's literally writing on a UDP socket. I only bring it up because it's getting to be more, and it's funny how important this has gotten for collecting data. Every one of our server environments codes has the ability to talk to this and send it, whether you're in ferries or you're in cars. And what an event is what it sounds like. We don't want to put duration-based things in event, but spontaneous events that are instrumentation. Instrumentation in Toontown is, I got a jelly bean. That's what we think instrumentation is. I earned a hit point. It could be as funny as, I think I found a hacker. Things that you want to get to a central file that's treated with a little more respect than a local log file that we're probably just going to purge in a week or something. Something you want to be, we've never thrown a single event out. I have 7 years of Toontown events sitting on a hard disk. I can go back and audit every chat message, every jelly bean ever earned, everything. I know those. You can imagine the value there. So we want to actively encourage instrumentation in all our systems. We've also recently exposed to the clients a virtual DC object called, I don't remember the name, I can get the name for you, that lets you post events into this. It does some scrubbing of the thing, make sure it's not right, and the event could be, we've extended the system a little, could be as much as, hey, I need moderation help. There's somebody here harassing me. I've got a pedophile chasing me. I've got things like that that we've got to be concerned about in our products. And it could be as simple as client earned a jelly bean. You could decide to record a jelly bean through that interface instead of through an AI's interface. The feature is now available and those type of things. So that's what the event logger does. So just think of it as a big way to put stuff to a disk file that's a log, that's an event space. And it's unbelievable how valuable this is to diagnosing it if we take the time to put enough instrumentation in, if we take the time to extend it and add things. Joe Shockett spends his life living inside there grepping and setting and guessing about why customers are behaving the way they're behaving. DB state server. Okay, at one point in our life, we were just dreaming about bringing up a thing called Pirates, and we learned some lessons in Toontown. One of the lessons we didn't like is that everything I described about this instance of this object in a state server working implied there was an object in a state server. The reality is, Toontown in its life has had, 15 million avatars created. I just can't fit them all in memory. I can't load them all up. It doesn't make sense. You want to be a little scavenging about the behavior of this. You only want things in memory when you care about them. So we came up with the concept is we're going to put this special state server in place that lets us address things when they're not playing the game. So literally what the DB state server is it's smart enough to listen to everything possible in the database and listen to every possible channel. What we did to accomplish that is we added one more registration model to the channeling system. That registration model is you can listen to a channel by range. You can say, I want to listen to every channel between 100 million and 200 million. 300 million, there's some range of channels you want to listen to. And you can do that with one command, talk to the message director, and any message that's ever gets destined to any one of those channels will get delivered to you. So, and the main reason was historically we took our databases because we had to have unique DUIDs, and we confined the database sequence generator to a range. So it was a natural fit into that space. So the good news is now you have a way of registering to a range of channels if you want to abuse them. The only two people I know of that use it today is a DB state server and the database itself. So the database state server knows that he's hosting a particular database. What his job is to do is to give state server behavior to a database when an avatar is not playing, when an avatar is not in memory. It's real simple. It gets a message in, stores it in a queue of work, starts a query for the particular database element, gets it back. When he gets it back, he plays them, guarantees ordering and playing and the proper behavior. So that's kind of what the DB state server does. This affects Pirates and Toontown a lot. It's not affecting ferries or cars right now, because we don't use this type of database. It's a good thing. The reason this became a good thing was we needed an omnipotent way that would still broadcast to people when things changed, that I wanted to, the guy's offline, I want to remove my friendship to a friendship record. Well, the guy's not playing, your friend's not playing. How do you deal with these type of things? I wanted to give a guy a reward because they won a contest when you're offline or something like that. How do I get that into the system? So we had to have an omnipotent database space. At the same time when we came up with a thing called UberDog, when we talked about UberDog. UberDog are these servers, they're really just AI servers, but they're separated positional space. They have to do with things when you hear the word around here about UberDog, what we're saying is there's an omnipotent server. Omnipotent being, I should say omnipresent is really the right thing. It's not omnipotent, it's omnipresent. It's always available. It's always there. You can always go to it and say, give this guy 5 gold. That's a definition of an UberDog. It's a long, old, strange name, and that's really all it means. Anything that has nothing to do with a guy being in your world. It's not a stateful thing. He is always responsible for the behavior of something. That would be what we would call an UberDog in the history of things. You can tell them all over the map on this lecture. DB state server. Okay, so major features, and then we'll open up for some questions and see what happens. Client agent. In the grand scheme of the problems we had to solve, what does a client agent do? Client agent is a big participant in calling. Its job is, that's the calling we care about. I can probably buy a bunch of bandwidth here. Big network cards, gigabit, whatever. We can do things here. I can't buy a bunch of bandwidth here. This guy's got a cable modem. This guy's got a dial-up. This guy's got a, he's 48 miles away from us or 4,800 miles away from us. So his job is to facilitate network calling. He's really the start of all the network calling. So he's the one that deals with interest. He's the only one that even understands interest. Nobody else in the system understands interest. What that tells you as a developer, as an AI guy, he ain't talking to that guy. AIs have no location-based interest calling. The only interest calling AIs have is AI receive calling. There's a concept of the owning AI, a particular instance of an avatar, of a thing. What else do client agents do? Security. They are the gateway of the security. So a lot of times you'll hear me look at you and somebody will ask for something, I'll let you go, I don't know, man, that sounds pretty bad. We might have some issues if we turn that on. A lot of times I'll be worried about, and we've had some good people come at us. I'll be worried about the implications of, we're probably going to have to look a little closer at this record as it comes in. We can't trust it. Literally today in security model, AI, at least, the client agents literally guarantee every packet that comes in meets the DC contract. He validates it, if it doesn't, he logs you out. He doesn't mess around. This guy in security doesn't mess around. I love it because it solves most of my issues, because it usually happens to you developers during development, and you're motivated now to fix it. It's not a warning in the log. I'm not joking. This is not a good thing. Don't let it hit production type of space. So when he senses a security violation, even if it's a bad fat finger on the coder's piece, he's going to kick you out. The first one that he guarantees is parsability in the DC space. DC also has, and David recommended that you read the detail spec, it has some domain constraints you can put in it too. You can actually put some range logic and other type of constraints that have nothing to do with encapsulation and size of bits. There's some other features you can do, and he fully guarantees it. The way we do that, we share the same code. Almost every product we have has the exact same code dealing with DC systems. Other security, we put hand-coded code in here for things like chat, whisper, things that we think need a little more domain constraint logic. So think about whitelist chat. It's really just a bunch of text screens, and there's nothing to stop me from putting in here in my Toontown environment, hey little girl, meet me at the mall next Friday night. We can't have that happen. It's just not okay in our product. So we have hand-coded code in here, so it's the security god. Tons of code in the client agent. The other thing the client does, and I kind of drew it, think of the client agent as a giant funnel. Last thing I want to do is have 50,000 open sockets inside here just floating around and everybody connecting to everybody, and it's this giant chaos, and it would just kill us. We'd never be able to comprehend what's happening, more or less debug any problems. So they're also funnels. Think of them as a funnel. They take a bunch of connections and literally out the back of it have one connection. And I take all those packets and put them on and off one, and it's a way of getting this down to a manageable space. It's still very big. Pirates has 25 physical AIs, 25 physical worlds running. Toontown, I don't think has quite as many, but they're close. I don't see a Toontown guy in here. Client agent, message directories you get. The interesting news in production, when I draw this picture, this is what production looks like. Production has a bunch of client agents. It's got a bunch of message directors coming up. The reality is every single one of these processes has a message director in it. If they're running in different memory spaces, or if they're running in the same memory space, they must have a message director, because it's all about routing those messages. That's how everything in the system works. In production, not on your desktop, you'll literally see a separate machine that the production guys will call the message director. It's a dedicated box. We usually run in a star configuration, just like I've shown it here, where there's one big central message director that melts when we get too busy and all sorts of other bad things, but the reality is it's one message director. State servers, normally in the physical configuration on state servers, we have per box in production, we have a state server, and we usually put on the same box, because we buy 8x machines today, we put one state server and 6 world servers on the same box. Mainly my belief is if this box crashes, we're kind of hosed. Whether these guys go down, these guys go down, you might as well take it all down. The state server that's supporting the ships, the ferries, the worlds, the things that have to do with the box. The one exception to things that aren't there is we have in Pirates and Toontown, we have a thing called a database state server. Toontown is a host. There's one database state server for the whole site. It hosts every single avatar that's playing is in memory on this box. Every single doodle that's playing is on memory on this box. Every single house that's manifested is on memory on this box. I'm trying to think, are there other distributed database objects in Toontown? I'm looking at the doodle houses, estates. Estates is the one other. They actually have a thing called a state, which actually has values. So there's 4, they're all hosted on that box, is how it works. And the magic interaction works between these two. I'm trying to think what I've missed. Is there any obvious things I should be adding that I haven't talked about, guys? I've kind of just gone on a rant like I always do. Messaging by managed servers, game clients, client agents, custom functions, distributed class system. Man, we've gone full circle.
Hey Raj, what about par files?
Yeah, let's talk about par files. Okay. If you're a Python user, you've used the PRC files. Par file is just a way to get information and configure the state server. As you turn on features here, so it's conceptually, if I was to do it again, it'd probably be an XML file or something nowadays, would be the kind of the norm way to do it right now. It's a bunch of name value pairs. It's in a par file. So as you configure your space, if you go to the pre-builts and you want to download, it's going to give you a pre-built. If you don't have one, you'll get one. There's probably in there an example.par or something like that. I think it's local example.par I put in there. It's kind of how to get bootstrapped, and it's not uncommon to put one in for every show and those type of things. And you'll see very, very much interest in the par file. It's very classic. Some text string, things like client port, and I'm not even remember the exact ones on the top of my head. Port equals some value, and of course the par file is very loosely coupled the way it's built into the system. It doesn't care what you put in there. The bad news is it's going to try to interpret it as on this one. It's going to try to interpret it as a number. I can guarantee it. So you better get them right. There is a little bit of magic in the par file space without going into every line item, which I'm not prepared. I have to go dump them. There's just so many options in that space. There are concepts of sections in a par file. If you've ever been a Windows hack and deal around with INI files, a section is a section. You put a text string in here, it means only read that section if you're reading that section. So that's the first thing. So you put some text string between these square brackets, and you start here, that's a section. By the way, if you want to comment, first character needs to be a pound in the thing. It is what it is. That's what it is. At some point, God, I don't even remember off the top. Anybody know off the top of their head what the include a section value means? Nobody remembers. There's a way to literally say read a section. You know, gosh, squiggly squiggly equals this name. When that happens and it reads that before it gets to that section, it does exactly what it does. It means read that section or pass over the section. This helps a lot for the site guys when they build things. There's one other abuse you can do with this, and I think is it import or include?
Include.
Is it include? I'm a C guy. Use also a command that's include equals, and it's a file name. Then it's treated like a file name. And what that literally does is like a typical include statement, is it means parse that file also. This way in Pirates, I think that Pirates has heavy use of, what do we have? You probably have like one par, you have one per machine?
One par file per task.
Per task?
Yeah. So.
And you probably have 50 tasks.
Well, no, not well per task meaning like up on your board, a client agent has.
Okay, for major feature.
Yes.
So you got 10,
Yeah.
8 something par files.
Yeah.
And that way you can kind of control them, turn them on, and those type of things.
Yes.
What other this may be different than the Panda system or other systems, is the OTP server also reads every value in your environment and treats it like it's a par file entry. So the good news is, if you want to do something quickly, you don't want to go put it in the file, or you want to change something at runtime, you can stuff it in the environment. It also will read the command line like it's a par file entry. The hierarchy on that is literally it reads the command line, reads the environment, reads all files recursively until it gets done with all files, then rereads the command line. So the command line always wins, and it can bootstrap the rest. That's kind of the reason that it works. So for little changes, a lot of times, you guys, you don't do it every day. You're probably better off just hacking your local par. Most people just put a local par. The files it reads by default is it reads one no matter what called local par. The reason it reads local is we believe that local was intended to be the one on the local machine. It was a local configuration. The other thing it reads is whatever you happen to name the binary. If you rename the binary, it'll look up a different one. But whatever that binary name is before on Windows, before the .exe, or exactly what the name is on Unix, it looks for that .par in its lookup path, and it'll open that one also. So that had to do with some historic, when we had literally different binaries called message director, and we had different binaries called state server. So you didn't have to do some magic command line stuff, it just knew because of the command you were starting. Today we link them all into one binary in the space. So does that answer questions about the par? As much as I can answer in this type of setting and not being prepared. Anybody got any other questions? I've totally diatribed. There's got to be some issues. What did I just blow over and not cover well?
The database state server is still a little fuzzy. What's a good example? Like, would you use that for like a garage? Like, you know, if I want to send you a message but you're not logged in, for example.
Well, let's talk about what you're doing for your system. So what you've got now is you've got an Uber object. We've created an Uber dog object, and we'll call it the garage manager. Let's say we had a thing that's, well, the car manager. It's going to be your avatar manager. I got to believe in cars we're going to have a thing that's an Uber dog, it's called an avatar manager or the car manager. Now, there's two possible paths you could use. In reality, the car manager in cars is probably going to be a well-known name. Well-known names are just 64-bit numbers. We're going to, and usually they're in low range. You'll see the number like 26, 27. We use numbers like that to be well-known names. So it's just a contract that we've kind of agreed on ahead of time. You could, if you wanted to, talk directly to the car manager. You could come up with a protocol in DC space like, you know, give the car gas, you know, and there's and you could, and what you do there is instead of making it DB state server driven, you'd say, hey, car manager, fill up car and then the car number. You tell him what you're talking about. That would be, it's very classic, like an RPC, kind of a web RPC kind of space when you're thinking about it. It's, you know, I'm talking to a central server that's responsible to do this, a name server, and then I'm telling it the subject matter to do. You flip the metaphor a little, and when the DB state server would come in is, I don't know who the central server is. I don't want to know who the central server is. I already know how to give a car gas. I've been doing it forever in a state server. All my code does this. It knows how to do this. I want to learn another way to do it. It saves you the issue of having, when he's in the game, you probably have to do something different because you're going to send it to this guy. So the reason the DB state server is that exact reason there is I I want an equivalent behavior when he's in the game, because he's in the game, I'm going to give the gas, and as far as I'm concerned, the way the place a game is played is right there on the state server. That is the system of record of those RAM values and those things. So people in the game are saying, hey, car, fill yourself up with gas. It's a little different metaphor. Instead of car manager, please fill car 27 up with gas. It's saying, hey, on channel 27, I'm going to tell that car, fill itself up with gas. So what the state server does is, I don't have to have them all in memory. It knows to listen to everything between 1 million and 10 million or whatever it is, and he gets it, and he's smart enough to go out and rip the thing out of the database, bring it into memory, apply the changes he needs to do, possibly, if it's some change that needs to follow some other of the contract rules we've had, communicate that data to the recipients of that piece, and probably, right when he's done, throws it away. Throws it away. It also allows some really interesting things like, instead of having to invent we in Toontown, Toontown didn't have this. It has it now, it didn't have it day one. At one point in Toontown, we had this whole kind of waterfall startup motor that was about, hey, bring an avatar online. And I ended up with a bunch of code in this client agent that was, hey, I gotta read something for a database, I gotta bring it in here, I gotta put it on a state server, I gotta yank it, I gotta move it. Very ungeneral purpose, every time somebody went to change any flow on that, it was, hey, Roger, please, can you find some time to help me here? That type of thing. So when I already had a function called set location, that's really all I wanted to do, was set an initial location for the object. So literally the DB state server also knows how to manifest objects in the database. I want to give them a location, I want to give them an owner, I want to bootstrap the whole process, I want to unroll it. So it generalized a lot of that code that was very application driven. I think when we first built Toontown, I never envisioned there'd be a pirate. So I don't know if anybody else in Toontown, we didn't think we'd get to finish Toontown, more or less another one. More or less 4 now we're working on. It's unbelievable. So that's kind of what it does. The bad news is this does not play well with SQL servers. It's because I'm talking about objects. And SQL servers, they work okay in object space, but they want you to denormalize. They want to have referential integrity. They want to have some stuff that the DC system doesn't represent real well. And SQL servers don't represent objects well. That's not, anybody that writes SQL databases and try to write objects, they never quite match. You always end up in this kind of this weird translation layer. So what we're literally doing for ferries and cars right now is we're putting an UberDog approach in place. So on most cases, when you want to do offline behavior, you will not in cars, unless we change our mind and decide to add a feature to support you, have that. Cars will not have that, and will not have that in its space. We will not turn those on today for cars and ferries. We do turn them on for pirates and Toontown. What you'll have is an UberDog hanging off the side of here, probably reality talking to one of these. He'll have a dedicated state server that's his play toy, but he'll be dealing with we'll event at the little higher layer the ability to set his gas when he's not in the game. And it may not be as clean as you like. It may not be, but I'm not sure we gained as much as we thought we were going to gain by introducing some of we actually introduced some interesting complexities that aren't the best. So I don't know if that answered. Okay.
Scalability on that UberDog is going to be interesting.
I'm sorry?
Scalability on that UberDog is going to be interesting.
Yeah, the good news is, because again we've learned lessons, we've
Depending
looked
on
at
what you
pirates,
use it.
the good news is cars is way behind everybody else. So the good news is it gets to learn all the lessons.
Yeah.
So I believe today in cars and in ferries, our belief is very much we'll modulus things. We'll do exactly what we've done in other. We're not going to invent it. We saw you guys melt, and we're going to learn the lessons from you guys. So literally, that's our thought. We haven't physically ran down that path yet, but we don't think we're going to hit it. Right now in ferries, which is the only one that's kind of mature enough to look at, we believe it just doesn't, it's not quite, it's unless things get more robust, it's a pretty quiet space, really, when it comes to the clusters. Nothing like pirates, and it's probably even less than ferries. It's got a lot of telemetry, you got a lot of things you need to call and those type of things going on. There's not a lot of persistent database stuff. Now it does have a much more complicated schema, because we went to SQL space. I think our current prediction on ferries is we'll have about 1 billion records in one of our tables. Mainly because we normalized things that we have in some of our other things that are kind of, think of them arrays, think of your friendships. At Toontown, you have 50 friends. Well, if you take 5 million ferries and flip 50 by 5 million, you can get pretty big numbers pretty quick. Mainly has to do with inventory. They're kind of got a slotted inventory model. And right now in ferries, inventories, and I imagine it will in cars too. And We'll make mistakes, but it's better. We've learned from our past on that one.
And also, what we've done for some of the Uber dogs is they're actually web servers effectively, so you're sending transactions to
Okay.
a web server.
Oh, it's even uglier.
Which actually talks.
You-
also
you-
to
You've got
message
easy answers
records.
there then.
I'll show you what we got for ferries. Are we running out of time?
Hey,
Literally, ferries, the web server that's an RPC web server, which is XML on this end, has the OTP cluster on this end. They're connected to both. They service both, the same memory space can service both, and they're all hooked in that space. Yeah. So it seemed just as easy. I already got a Java VM running, and I've already got the code written to negotiate all these things. And ferries is extremely. In fact, we should cover that. We should talk a little bit about. There's certain things the OTP server does well, and certain thing it does really kind of bad. Again, the OTP server is about calling persistent security. It's a register subscribe model. It's not. You can use it for a point-to-point communication space. You can use it as an RPC engine if you really need to. It wouldn't be my first choice if I was going to build a bottom up. You know, if I only bring up one, I'd put it in there. But if I was starting to bring up something big that I need to do millions of these and have performance, well, I think our current model right now is, especially if it's client-driven RPC, where we're doing it from here, I think you got to seriously consider doing some almost HTTP-hosted RPC, mainly because it's just commodity. The HTTP environment, you just throw these things up, you can go horizontal. It's kind of a lot of people know this space. It's not a fine-tuned technology. And the other advantage you get by doing that, because those I know how to scale, it gives me more scaling in this cluster. One of our issues is, how do we get these big? This is a star mechanism today, and there's so much going on. Right now, Pirates, when Pirates is busy, this central message string has 200 megabit a second sustained flowing through it. Sustained, non-stop flowing through that thing. That was with 20,000 players. You know, we're supposed to get these sites to 100,000 players concurrent and those type of things. We're taking action to solve some of those technology issues, but one of the best actions we can take is let's don't put dumb things in here. What this does well is interest. What this does well is calling. Now, I only talked about location interest and AI interest. It's totally feasible in this space to abuse interest. We do it today for shard discovery in Pirates. I want to kind of know what's going on in this world, and I want to ask the question, tell me about the active shards. Tell me about things. So we literally today for Pirates or Toontown, or I think we're even doing the exact same in Ferries, is there's a magic zone number, just magic kind of well-defined understood space. Actually a magic well-defined 64-bit number because we just take it, put a comma 3 behind it or something when we say parent-child. And we